So in this video we have discussed about the complexity of algorithm. So what is called as a complexity of algorithm. So complexity of algorithm refers to the measure of the time that it will be need to execute and space it will need to store all data, input, temporary and output. Hence these two factors define the efficiency of algorithm. So complexity of algorithm, what's the complexity of algorithm? To measure the time that will as well as the space. So when you analyze the algorithm, if you are not analyze the algorithm, it affects the performance of the program. So that's only you have to analyze. So how they are analyzed? Honestly, how will you analyze it? So based on the efficiency only you have to analyze. So what is the efficiency? What the efficiency? How will you find the efficiency based on the complexity of algorithm? Based on the complexity of algorithm. The two factors of algorithm complexity are time factor as well as space factor. What is called as time factor? Time is measured by counting the number of key operations. Time is measured by counting the number of key operations required by the algorithm. We are comparing, based on we are comparing means key operations they execute. Space factor. Space is measured by counting the maximum memory space required with the algorithm to run. Okay, this is based on the two factor only. You have to measure the complexity of algorithm. Next, complexity of an algorithm divided into two types. One is space complexity and time complexity. So what is space complexity? Go through that. The space complexity of algorithm refers to the amount of memory used by different type of data type variables, program instruction, constant value, and few other things like function call, recursion, in order to calculate the space complexity. The big O notation is used to represent an algorithm space complexity. So big O means you have to measuring unit to measure the algorithm unit, that is a big O. So what's next? What is called as space complexity? Space complexity is the sum of auxiliary space and space used for input values. Auxiliary space means some of the inputs are using temporary, that is space used for input. So you have to feed some input, that is the space. The space is required for algorithm for the following reason. To store program instruction, you need a space. To store track of constant value, you need a space. To store track of variable values, you need a space. To store track of function calls and jumping state, very very important. Space is required for the following reason. It is to store to store the instructions, program instruction. We need a space. Constant value, you need a space. Variable value, you need a space. Function call and jumping statement, you need a space. So the space complexity of an algorithm is calculated by determining the following two components: fixed part as well as a variable part. It is fixed part is referred to space that is definitely required by the algorithm. Example: input value, output value, program size. Variable part is this refers to the space that can be different based on the implementation of the algorithm. For example, temporary variable, dynamic memory location, recursion stack space, etc. So example formula space complexity S of P of any algorithm S of P equal to C plus SP of I, where C is the fixed part, S of I is the variable part of the algorithm, which depend on the characteristic I. Okay. Next also memory usage while evaluation. Whenever we execute any program in our computer, then it takes some extra space from our computer. The extra space is taken by those programs because of three main reasons which are stated below. One, instruction space. Whenever we compile our code in the compiler, that we need some memory in our computer, our system to keep to store that code so it's executed further. So instruction space is the space where the code is stored. The environmental space stack. This space is used as to store the address of the partially executed function. So partially executed function is the function which calls the other function without executing itself. So a function call other function, that is a partially executed function, because as we know sometimes the function call itself or any other function, so the data of the previous function is stored pushed on the stack until further execution of the previous function is called. So this is memory usage. Another one, data space. The data space is used to store the data variable at constant program, and then they are updated during further execution. But nowadays, during the calculation space computation of any program, we just consider data space and ignore the add-on stacks and instruction space. Now we consider only a data space only. We ignore the environmental as well as instruction space. Next, we go to the time complexity. The time complexity of any algorithm refers to the amount of time that is required by the algorithm to execute and get the result. This can be for normal operations, conditional if else statement, loop step, etc. So once again, the time complexity of algorithm refers to the amount of time that is required by the algorithm to execute. Amount of time, how long time it required to execute a program. So that is the time complexity. How will you measure? It is also measured by connotation. Because notation. How will you calculate the time complexity? Time complexity, say time complexity, or otherwise called as the order of growth. The time complexity is calculated primarily by counting the number of steps required to complete the execution. The time complexity of algorithm is also calculated by determining the following two components: constant time part as well as variable time part. Constant time part, any instruction that is executed just once comes in this part. For example, input, output, defaults, switch, arithmetic operations. Variable part, variable time part, any instruction that is executed more than once, say n times, comes in this part. So here also we are using this formula, time complexity TFP of any algorithm, TFP equal to C plus TPFI. So one is a constant time part as well as a variable time part. So any instruction that is executed just one means it is called as a constant time. If any instruction that is executed number of times, that means it is called as a variable part.